Alright. Hey guys, so welcome back to another video. Today I'm going to be talking about the washer method, right? Well, if you understand the washer method, you'll understand the disk method, but basically they both relate to the same idea. Think about to whenever you learned how to do like geometry, right? You learn how to do the volume of shapes. The volume of shapes is literally just the height times the area of the base. No matter what shape you're dealing with, it's always the height times the area of the base. So, that being said, um, we can apply that idea to um, finding the volume using calculus, right? So what we need first is like, okay, well, let's say I have this image right here. It's a washer problem. So it's a cone with a hole in it. So let's say that I have this surface. I want to find the volume of it. So what I need first is obviously I need to find the area of the base and the height, right? The way that we do this is we're basically going to take cross sections of the cone and we're going to add them all together, right? So I'm going to take a slice of the cone, find the area of that, and I'm going to keep doing that and adding all of those areas together, right? How we're going to do that, we're going to start with what we know is our adding machine in calculus. We're going to use a definite integral, right? So we know that our volume is going to be a definite integral, right? So we need to know from what point to what point are we going to take the definite integral, right? That's going to be our height, right? So for our case, we want to take it from a to b, right? So we're going to take a definite integral from a to b, right? Okay, well, so that takes care of like the height. Well, what's my base? How am I going to find that? My base is going to be this washer that I have in purple, right? So this, we can kind of illustrate it like this. So, right, it's a washer. It's going to look something like this, right? So how are we going to find the area of this donut-looking thing? The area of this is just going to be the area, like all of this area, right, of the big circle, and we're going to subtract the area of the little circle, right? And that makes sense, right? So, but how we're going to figure out how to do this is, okay, well, how do I get the area? We'll do the area of the small circle first. So for the area of the small circle, that small circle is given by this blue ring right here. That blue ring is given by the function f of x, which I realize I've not written. So this is f of x. The radius, as you can see from my picture, is just the x-axis up until it hits the line given by f of x, right? So this radius is going to be given by the value of f of x, right? So this is the center of the circle. This radius is just going to be given by f of x, right? Okay, now what about the big circle? That big circle is going to be given by g of x, right? Because that big circle is going to go from that x-axis up until you hit g of x, right? So this is going to be g of x. Okay, well now if I take the difference of those two areas, right? This is going to be, the difference of this is going to be, well, what's the area of a circle? That's pi r squared. So the area of a circle is given by pi r squared. For this washer, I have to take the difference of two circles. The area of the big circle is going to be given by pi times g of x squared minus pi times f of x squared, right? Where f and g represent the radius of each circle. Therefore, my volume, right, this is going to be this right here is going to be the base. That's going to be the area of the base, right? So this is going to be pi times g of x squared minus pi of f of x squared dx. right? And that's how we're going to get the volume, right? And so depending on what kind of shapes we have, the cross sections may be different. But that's pretty much the whole gist of how we're going to do these volumes. So anyways, that's it for me today. I hope you guys learned something. So thanks for watching.